Today, still section 3.3, 3.4, and 3.5. There are 10 derivative formulas in these three sections. I divide these 10 formulas into two groups. The formulas in the first group work for general functions, and the formulas in the second group are only for special functions. Take a review about the formulas. Formula number 1, constant multiple rule. A constant times a function, then derivative is the constant times the derivative. This formula says that we can move the constant outside a derivative. Formula number 2, summation rule. Derivative of a sum is sum of the two derivatives. Number 3, difference rule. Derivative of a difference is the difference of the two derivatives. Number 4, product rule. Derivative of a product is derivative of the first function times the second function plus the first function times the derivative of the second function. Number 5, quotient rule. Derivative of a quotient is the derivative of the numerator times the denominator minus the numerator times derivative of the denominator, or divided by the square of the denominator. Number 6, derivative of a constant is 0. Number 7, derivative of a power function is the power times x to a minus 1. Number 8, derivative of an exponential function is the exponential function times natural log of a. A special case, derivative of ex is ex. Number 9, derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant square. Number 10, derivative of a log is 1 over x times natural log of a. Derivative of a log of absolute value of x is 1 over x times natural log of a. The difference between these two formulas is in the domain. The domain is positive x, and the domain for this formula is any number except 0. Special case, derivative of natural log is 1 over x. Derivative of natural log of absolute value of x is 1 over x. Here are some basic algebraic formulas that we often use. For example, a plus b squared is a squared plus 2ab plus b squared. A to the third minus b to the third can be factored into a minus b times a squared plus ab plus b squared. X to a times x to b is x to a plus b. X to a, then the whole thing to b is x to a times b. Now, examples. Example 1, find the derivative of this function. This function is a quotient. So by quotient formula, the derivative of the function is derivative of the numerator times denominator minus numerator times derivative of the denominator, then all divided by the square of denominator. In this expression, there are two derivatives that we need to compute. We need to compute this derivative and this derivative. Let me compute them somewhere. After I get the result, I put the result back here. For this derivative, because the function is a product, so I use the product rule to compute this derivative. By product rule, it is derivative of the first function. The first function of this product is x minus 1 times the second function plus the first function times derivative of the second function. Apply the difference rule here and here, then we get this equation. Move the number 2 outside this derivative, then we get this equation. Now, derivative of x is 1. Derivative of 1 is 0. Derivative of x squared is 2x by this formula. Derivative of 1 is 0, so we have this equation. Simplify this expression, we get this equation. Distribute 4x to x and to 1, we get this equation. Combine the first term and the third term, then we have this equation. So derivative of this product is this polynomial. For this derivative, by difference rule, we have the derivative is derivative of x to the third minus derivative of 1. X to the third derivative is 3 times x squared by the formula here. Derivative of 1 is 0. Therefore, this derivative is 3x squared. Now, put this result here and put this result here. Then derivative of the function f is this quotient. Because this example doesn't require us to simplify our result, so we can stop here. We don't need to simplify this expression. This is the answer to this example. Example 2, find the derivative of the function by first simplifying the expression. The function is a quotient, so we can apply quotient rule to compute its derivative. But according to this example, we need to simplify the function first before we compute derivative. Factor x out from the numerator and from the denominator. Then we have this equation. Factor the polynomial x squared minus 6x plus 8. Then we have this equation. Cancel x minus 2. Then we have x minus 4. This function turns out to be simple. It is x minus 4. Now, take derivative on the function. By difference rule, then we get this equation. X derivative is 1. 4 derivative is 0. So the derivative of this function is 1. Example 3. Use the following table, this table, to find the derivative. This notation means compute the derivative first. After getting the result, plug in the number 4 in x. The function in this derivative is a quotient. The numerator of the quotient is f times g, and the denominator of the quotient is x. Apply quotient rule to this derivative, then we have this equation. In this expression, there are 2 derivatives to compute. This one and this one. Derivative of x is 1. Derivative of f times g, we can apply product rule to get this equation. Simplify this expression a little bit, then we have this equation. This is the result of this derivative. Now, plug in the number 4 in x, then we have this equation. Use the given table to determine the function values. For example, f derivative f4. The third row of the table is for f derivative. When x is 4, the value of f derivative is 1. So this guy is 1. G of 4. The fourth row of the table is for g. When x is 4, g, the value is 3. So g of 4 is number 3. Do the same thing for the other function values. Then we have this equation. Calculator, then this number is 7/8. Therefore, the derivative of this quotient f4 is 7/8. Example 4. Let Bg be x squared times f minus g, where the graphs of f and g are shown in this figure. Find the derivatives of Bg f5 and f3. To find these 2 derivatives, we first compute the derivative of Bg at x. Please note that all the 10 formulas are about the derivatives at x, not at some concrete number. Take derivative on Bg. Then we have this equation. By the difference rule, this derivative is equal to derivative on the first term minus derivative on the second term. So we have this equation. to compute this derivative, because the function is a product x squared times function f. So we apply the product rule. By product rule, this derivative is derivative on the first function times the second function plus the first function times derivative on the second function. Product rule. Then derivative of x squared is 2x by this formula. So this is the derivative of bit g at a general point x. Now, for the derivative at point 5, plug in the number 5 in the x here. Then we have the derivative of bit g at 5 is this number. Simplify this expression a little bit, we get this number. Now, go to the figure to determine the function values. The blue curve is the graph of function f. At the point x is 5, the height of the blue curve is 3. Therefore, the function value f of 5 is equal to 3. To determine the derivative of f at the point 5, draw a tangent line to the graph of the function. At this point, draw a tangent line. The tangent line is this line. Then derivative is the slope of this line. By slope formula, y2 minus y1 over x2 minus x1, the slope of this line is 5 minus 1 over 7 minus 3. It is negative 1. Therefore, derivative of f at the point 5 is negative 1. Now, to determine the derivative of g at the point 5, draw a tangent line to the graph of g. At this point, draw a tangent line. Then the tangent line is this red line. Derivative is the slope of this red line. By slope formula, this point is 7, 0. By slope formula, y2, 4 minus 0 over x2, 3 minus 7. So the slope of this line is negative 1. Therefore, derivative of g at 5 is negative 1. Yeah, here is the computation of the function value at 5, derivative of f at 5, and derivative of g at 5. Now, plug in this data in this expression. Then we get derivative of bit g at 5 is 56. Now, for the derivative of bit g at the point 3, plug in the number 3 in the x here. Then we have derivative of bit g at 3 is this number. Simplify this expression a little bit, then we get this number. Now go back to the figure to determine the values of these functions. At the point 3, the height of the blue curve is 1. Therefore, function f, its value at free is equal to 1. Yeah, f of free is 1. Now, determine the derivative of f at the point free. This is the slope of the tangent line at the point free. At the point free, the graph of f has a corner. Recall that when the graph of a function has a corner, there the graph has no tangent line, because derivative is slope of tangent line. Low tangent line, therefore, at the corner, low derivative. Therefore, the derivative of the function f at the point free doesn't exist. So this expression is not computable. Therefore, the conclusion is derivative of bg at the point free doesn't exist. Example 5. Let f be this function. Part A, simplify the expression for function f by writing it in terms of sine and cosine. Then, compute the derivative. Recall that all the trigonometric functions can be expressed in terms of sine and cosine. Part B, use the quotient rule to differentiate the function f. Part B means don't simplify this function. Directly apply the quotient rule to compute the derivative. Part C, so that your answers to part A and part B are equivalent. That means that so that the answers in part A and part B, they are the same answer. Solution to part A. Write the function f in terms of sine and cosine. Recall that secant is 1 over cosine. Tangent is sine over cosine. Therefore, we have this equation. To remove the denominator cosine, multiply the top by cosine, multiply the bottom by cosine. Numerator times numerator, 1 over cosine times cosine. It is 1. Denominator times denominator. Distribute cosine to 1. Cosine to sine over cosine. Then denominator is cosine plus sine. Therefore, the function f is simplified to 1 over cosine plus sine. Now, compute the derivative on function f. Function f is a quotient. The numerator is 1. Denominator is cosine plus sine. By the quotient formula, this derivative is derivative on the numerator times denominator minus the numerator times the derivative of the denominator, then all divided by the square of the denominator. For this derivative, we can apply summation formula. This derivative is derivative on cosine plus derivative on sine. Now, derivative of 1 is 0. Cosine derivative is negative sine. Derivative on sine is cosine. So this is the derivative of function f. Now simplify this expression. 0 times cosine plus sine is 0. So we have this equation. Distribute the negative to the two terms, then we get this equation. This is the derivative of function f. Solution to part B. Use the quotient rule to differentiate the function f. By the quotient rule, derivative on function f is derivative on the numerator secant times the denominator 1 plus tangent minus the numerator times the derivative of the denominator, then all divided by the square of the denominator. Apply summation rule here. Then we have this equation. Derivative of secant. From the bulk, it is secant times tangent. Derivative of 1 is 0. Derivative of tangent is secant square. Simplify this expression a little bit, then we get the answer. This is the derivative of function f. Solution to part C. So that your answers to part A and part B are equal. Let me start with the answer in part B. Write the answer in part B in terms of sine and cosine. Secant is 1 over cosine. Tangent is sine over cosine. This tangent is sine over cosine. And this tangent is sine over cosine. Secant to the third is 1 over cosine to the third. Now, I want to simplify this expression to get the answer in part A. To simplify this expression, multiply the top by cosine square, the bottom by cosine square. Then we have this equation. A fraction times a fraction is the numerator times the numerator, and the denominator times the denominator. Then we get this equation. Write the product here as this by this formula. Then distribute cosine to 1, cosine to sine over cosine. Then this denominator is cosine plus sine square. Distribute cosine square to this term and this term. Then this numerator becomes this. Now, distribute sine to 1 and to sine over cosine. Then we have this equation. Combine the second term and the third term in this numerator. Then we have this equation. Sine square minus 1 by this formula is negative cosine square. In this fraction, cancel 1 cosine, then we get this equation. This is the answer in part A. Therefore, the answers in part A and in part B, they are actually the same answer.